Hi guys, welcome back. Domain 3 Architecture and Design, Chapter 3.5 Explain the security implications of embedded systems. So we are going to see the topics are listed here. So SCADA, ICS, Smart Device IoT, RTOS, System on a Chip, HVAC, printer, camera systems, special purpose. We will see one by one. Embedded system, one that has software embedded within the computer hardware, usually within read-one memory. So an embedded system is computer implemented as part of large system. The embedded system is typically designed around a limited set of specific functions in relation to the large product of which it is components. It may consist of the some components found in typical computer system, or it may be microcontroller. Example of embedded systems include network attached printer, smart TVs, HVAC controls, smart applications, smart thermostats, embedded smart systems in vehicles and medical devices. So for example, you can see in the pictures there's a lot of features out there, a lot of components and with one single plate of circuit board. Security concerns regarding the embedded systems include the fact that most are designed with their focus on minimizing cost and extraneous features. This often leads to a lack of security and difficulties with upgrades or patches. Because an embedded system is a control of mechanism in the physical world, a security breach and could cause harm to people and property. A static environment is a set of conditions, events and surroundings that don't change. In theory, once understood, a static environment doesn't offer new or surprise elements. In technologies, static environments or applications, OS, hardware sets or networks that are configured for a specific needs. A static IT environment is any system that is intended to remain unchanged by users and administrator. The goal is to prevent or at least reduce the possibility of user implementation change that could result in reduced security or functional operations. So however, although the term static is used, there are no truly static systems. There are always the chance that a hardware failure, a hardware configuration change, a software bugs, a software setting change, or exploitations may alter the environment, resulting in undesired operating parameter or actual security intrusions. Many embedded systems are implemented as static solutions. It is important to understand the various ways to protect the stability and security of embedded or static systems. Static environment embedded systems and other limited single-purpose computing environments need security management. Although they may not have a board and attack surface and are not exposed to many risks or general-purpose computer, they still require proper security governance. So we will see the SCADA, the next one, ICS and SCADA. ICS is an industrial control systems, encompasses several types of control systems and associated instrumentations used for industry purpose controls. SCADA, supervisions controls and data acquisitions. So it stands for supervision controls and data acquisitions used by utilize and manufacturing to collect data from factories, plants or other remote locations and forwards it to central computers that manage control the system. PLC is a programmable logic controllers, a single-use computer used manufacturing. Security, access control, monitoring. So SCADA is a supervision controls and data acquisition. So supervisory control and data acquisition is a type industry control system. And ICS is form of computer management device that control industry process and machine. SCADA is used to across many industry including manufacturing, fabrications, electricity generations and distributions, water distributions, sewage processing and oil refining. A SCADA system can operate on standalone device, be networked together with other SCADA systems, or be networked with a traditional IT system. Most SCADA systems are designed with a minimal human interfacing. Often they use mechanical buttons and knobs or simple LCD screen interface. However, network SCADA device may have more complex remote control software interface. In theory, the static designs of SCADA and the minimal human interface should make the system fairly resistant to compromise or modifications. Thus, little security was built into SCADA device, especially in the past. But there have been several well-known compromises of SCADA. For example, Stuxnet delivered the first ever rootkit to a SCADA systems located in the nuclear facility. Many SCADA vendors have stated implementing security improvement into their solutions in order to prevent or at least reduce future compromise. So, smart device. So wearable, you can see the lot of technology they use. The wearable technology like a smartwatch, exercise or medical device, often communication through Bluetooth. Home automations is a security camera, locks, lights, thermostats, sound systems, personal assistants, communications via Wi-Fi. So smart device are a range of mobile devices that offer the user a plethora of customization options, typically through installation apps, and may take advantage of on-device or in the cloud artificial intelligence processing. The product that can be labeled smart device are constantly expanding and already include smartphones, tablets, music players, home assistants, extreme sports camera, and fitness trackers. Android is a mobile device OS. It's based on Linux, which was acquired by Google in 2005. In 2008, the first device hosting Android were made available to the public. The Android source code is made open source through the Apache license, but most devices also include proprietary software. Although it is most intended for use on phone and tablets, Android is being used on a wide range of devices including televisions, game consoles, digital camera, microwaves, watch, e-reader, cordless phones, and Sky Googles. The use of Android in phone and tablets is not a good example of a static environment. So these devices allow for a wide range of user customizations. You can install both Google Play Store apps and apps from unknown external source, such as Amazon App Store, and many devices support the replacement of default versions of Android with customized or alternate versions. However, when the Android is used on other devices, it can be implemented as something closer to static system. Whether static or not, Android has numerous system vulnerabilities. These include being exposed to malicious apps, running scripts from malicious websites, and allowing insecure data transmissions. Android device can often be rooted in order to grant the user full root level access to the device low level configuration setting. Rooting increases device security because all running code inherits root privilege. Improvements are made to Android security as new patches are released. User can adjust numerous configuration settings to reduce vulnerabilities and risk. Also, user may be able to install apps and add additional security features to the platform. But iOS is mobile device OS from Apple that is available on the iPhone, iPad, iPod, and Apple TV. iOS is not a license for use on any non-Apple hardware. Thus, Apple is a full control of the feature and capability of iOS. However, iOS is also a poor example of static environment because user can install any of over 1 million apps from the App Store Apple App Store also is not often possible to jailbreak iOS, allowing user to install app from third parties and gain greater control over low level settings. Jailbreaking an iOS device reduces its security and exposes the device to potential compromise. Users can adjust device settings to increase an iOS device security and install many apps that can add security features. So next topic, IoT. IoT is system, interrelated computing system, mechanical and digital machines, objects, animals or people that are provided with the unique identifiers and the ability to transfer data over a network without requiring human to human or human to computer interaction. So IoT is a new subcategory or even a new class of device that are internet connected in order to provide automations, remote controls or AI processing to a traditional or new appliance or device in a home or office settings. IoT device are sometimes excuse me. IoT device are sometimes revolutionary adaptations of functions or operatings we may have been performing locally and manually for decades, which we wouldn't want to ever be without again. Other IoT devices are nothing more than expensive gimmicky gadgets after the first few moments of use and forgotten about and is discarded. The security issues related to IoT are about access and encryptions all already resulted in numerous home and office network security breaches. Additionally, once an attacker has remote access to or through an IoT device, they may be able to access other devices on the compromised networks. When electing to install IoT equipment, evaluate the security of the device as well as the security reputations of the vendor. If the new device doesn't have the ability to meet or accept your existing security baselines, then don't compromise your securities just for flashy gadgets. So SOCs, system on a chip. A system on a chip is integrated security IC or chip that has all of the elements of a computer integrated into a single chip. So this often includes the main CPU, memory, GPU, Wi-Fi, wired networking, peripheral interface such as USB, and power management. As you can see in the picture right side, in most cases the only item missing from a SOC compared to a full computer is bulk storage. Often a bulk storage device must be attached or connected to this SOC to store its program and other files. Since the SOC usually contains only enough memory to retain its own firmware or OS. The security risk of SOC include the fact that the firmware or OS of an SOC is often minimal, which leaves little room for most security feature. An SOC may be able to filter input such as by length or escape meta characters, to reject unsigned code, provide basic firewall filtering, use communication encryptions, and offer secure authentication. But these features are not universally available on all SOC products. A few devices that use a SOC includes the mini computer Raspberry Pi, fitness tracker, smartwatches, and some smartphones. So RTOS, real-time operating systems, an operating system intended to serve a real-time application that process data as it comes in, typically without buffer delays, designed to have zero latency, military spaces, example space. So is designed RTOS is a design to process or handle data as it's arrive on a system with a minimal latency or delay, and as I said before, an RTOS is usually stored on read-only memory and is designed to operate the hard real-time or soft real-time conditions. A hard real-time solution is for mission-critical operations where delay must be eliminated or minimized for safety, such as autonomous cars. A soft real-time solution is used when some level of modest delay is acceptable under typically or normal conditions, as it for most consumer electronics, such as the delay between digitizing pen and graphics program on a computer. RTOS can be event-driven or time-sharing. An event-driven RTOS will switch between operations or tasks based on the pre-assigned priorities. A time-sharing RTOS will switch between operations or tasks based on a clock interruption or specific time interval, and RTOS is often implemented when scheduling or time is the most critical part of the task to be performed. A security concern using RTOS is that these systems are often very focused on single purpose or leaving little rooms for security. They often use customs or proprietary code, which may include unknown bugs or flaws that could be discovered by attackers. And an RTOS might be overloaded or distracted with the bogus data it sets or process requests by malware. When deploying or using RTOS, use isolation and communication monitoring to minimize abuses. HVAC. HVAC is heating, ventilations, and air conditions. Many user computers network or small technology to regulate airflow and temperatures. Yes, it can be HVAC can be controlled by an embedded solutions, which might as known as a smart device or IoT device. So we were discussed about this in previous topics, the smart device for security issues, something like that. So physical security control protect against a physical attack, while logical and technical control only protect against logical and technical attack. You can see the list. Security. The security is a networking, partitions, segmentations, and access control monitoring. So as we discussed. Printers, MFDs. Multifunction device used for network printing, scanning, and copying. Web accessible. Generally little access control. So we were discussed this in the previous sections on the printers, MFDs under peripherals. So if you guys missed that, you can also check the previous videos. So a printer or MFD can be considered on embedded device if it has integrated network capabilities that allow it to operate as independent networks node rather than a direct attached dependent device. So thus, network attached printers and other seamless devices pose an increased security risk because they often house full-fledged computer within their chassis. Network security managers need to include all such devices in their security management strategy in order to prevent this device from being the target of attack. Used to house malware or attack tools or grant outsider remote control access. Special purpose device. The concept of embedded system is rapidly expanding as a computer control, remote access, remote management, automations or monitoring, and AI processing are being applied to professionals and personal events, activities, and tasks. In addition to the concept mentioned previously in the section, There are a handful of additional special purpose embedded systems. You should be familiar with this. The included mainframe, game console, medical device, vehicles, and aircraft, as you can see here. So mainframes are high-end computer systems used to perform highly complex calculations and provide bulk data processing. All mainframes may be considered static environment because they were often designed around a single task or supported a single mission critical. This configuration didn't offer significantly flexibility, but they did provide for high stability and long-term operation. Many mainframes were able to operate for decades. So the medical device, a growing number of medical devices have been integrated with IoT technology, remotely accessible for monitoring and management. This may be a great innovation for medical treatment, but it also has a security risk. All computer systems are subjected to attack and abuse. All computer systems have faults and failing that can be discovered and abused by an attacker. Although most medical device vendors strive to provide robust and secure products, it is not possible to consider and test for every possibility of attack, access, or abuse. There have already been several instances of medical device being remotely controlled, disabled, accessed, or attacked with the DOS. When using any medical device, consider whether remote access, wired or wireless, is essentially to medical care is providing. If not, it may still make sense to disable the network features of the medical device. Although the breach of the personal computers or smartphones may be inconvenient or embarrassing, the breaches of medical device can be life-threatening. Vehicles. In vehicle computing systems can include the components used to monitor engine performance and optimizing braking, steering and suspensions, but can also include in dash elements related to driving, environment controls, and entertainment. Early in vehicle systems were static environment with little or no ability to adjust or change, especially by the owner driver. Modern in vehicle systems may offer a wide range of capabilities, including linking a mobile device or running custom apps. In vehicle computing systems may or may not have sufficient security mechanism. Even if the system is only providing information such as engine performance, entertainment, and navigation, it is very important to consider what, if any, security features are included in the solution. Does it connect to the cloud service or communications encrypted? How strong is the authentication? Is it easily accessible to unauthorized third parties? If the in-vehicle computing system is controlling the vehicle, which might be called automated driving or self-driving, it even more important the security be major design element of the systems. Otherwise, a vehicle can be converted from a convenient means of transference to a box of death. Aircraft, unmanned aerial vehicles, UAV. Automated pilot systems have been part of an aircraft for decades. In most of the airplanes that you have flown on, a human pilot was likely only in full control of the craft during takeoff and landing, not always even then. For most of flight, the autopilot system was likely in control of the aircraft. The military, law enforcement, hobbyists have been using unmanned aerial vehicles for years, but usually under remote control. Now, with flight automation system, UAVs can take off, fly to destinations, and land fully autonomously. There are even many retail business experiments with, and in some countries implementing, UAV delivery of food on and or other package. The security of automated aircraft and UAVs is a concern for all of us. Are their systems secure against malware infections, single disruptions, or remote control takeover, AI failures, and remote code executions? Does the UAV have authenticated connection to authorized control system? Or the UAV's communications encrypted? What will the aircraft do in the event that all connected with the control system is blocked through DOS or single jamming? Your compromised UAV could result in the loss of your pizza or damaged product, a few broken shingles, or severe bodily injury. So move on, next slide. So securing embedded device. So those I made a questions here: secure by design and default, secure integrated in technology, system hardening, shielding from electromagnetic interfacing, network systems, and encryptions. In those I already made a questions. These all are the very important as per the security posture. I mean, the security embedded postures is very important. So that's it, guys, for this video. So please subscribe my channel. Please press the bell button to get more updates. So share the video if you like. Thank you so much. Have a good day. Bye bye.